Okay, let's look at the next 6 questions from your benchmark. Number 19 says the image shows a food chain. Let's study it. We've got the sun, the energy giver, the seaweed, which is the producer, eaten by a small fish, eaten by a large fish, eaten by a pelican. Where does the producer in this food chain get its energy? Producers produce their own food, and only one thing can do that. That's a plant through photosynthesis. So where is the seaweed getting its energy? It's not eating anything. It's getting its energy from the sun. Letter D on number 19. Producers get their energy from the sun. Photosynthesis, remember, needs sunlight, carbon dioxide, and water. Okay, number 20. The map shows the location of some earthquakes, volcanoes, and ocean trenches around Japan. This sounds like our Ring of Fire lesson we did the other day. All right, so let's take a see what this looks at. Earthquake strength, the darker the dots, the harder the earthquake was. So right in here was a very hard earthquake. The volcanoes are the little dots there, little triangles. Ocean trench, where deep places in the ocean are the lines. Okay. Which 3 patterns are supported by the information on these maps? Volcanoes form near where plates come together. Okay, so there's a Philippine Sea plate, the Eurasian plate, the Pacific plate, the Akatosh plate. Are the volcanoes forming around those lines there? They sure are. So I think A, it says we got to pick 3. So I think A would be one. An ocean trench is located along the Pacific plate. Ocean trench, Pacific plate. It looks right to me. I think B is correct. Earthquakes happen around areas where plates come together. Okay, where's the earthquakes? Okay, I got to go back to the letter A. Sorry. I looked at the earthquake map for letter A. Volcanoes form where plates come together. So these plates come together here, here, and here. What do you think? I don't think it is letter A because these plates are coming together. The plates are represented by these lines here. Do you see a pattern there? They're more on this line right here, this land area. So I don't think it's A. I still think it's B. Earthquakes happen around areas where plates come together. Definitely. There's a lot of earthquakes around these lines here. So let's do B and C so far. Strong earthquakes happen on land far away from where plates meet. I don't know that this is far away from where plates meet. It's kind of between 2 plates. There are more volcanoes in the Eurasian plate compared to the Oshkosh plate. Okay, volcanoes here. Oshkosh, that's where all the heavy ones are, so I don't think it's E. Now, I know it's B and C. A, volcanoes form near where plates come together. We're looking at the volcanoes here. The plates are right here and right here. I guess the map kind of supports that, doesn't it? Because they're on the line. Some of them are right here, right here. What was the other one we couldn't? Strong earthquakes happen on land far away from where plates meet. I don't think that's far away from where plates meet because there's some dark ones right here, and here's where plates are meeting. So this one is going to be A, B, and C. That's the only 3 that it could be. That's a difficult question. What we need to know in our standard is basically this. Where plates meet is a likely place where there will be ocean trenches and volcanoes and earthquakes. So let's think about these tectonic plates, okay? When they rub together, they form an earthquake, okay? When they pull apart, they can let lava come up and form a volcano, okay? And then under the ground, if they pull apart, it can form a deep ocean trench in the ocean. So volcanoes, earthquakes, ocean trenches can all occur where those tectonic plates meet. Okay, let's remember that. That was a tough question. The image shows a marsh food web. An animal is missing from position X, so something's missing here. A student lists 4 animals that live in a marsh and what each animal eats. A coyote eats small mammals, birds, insects, and plants. Red-bellied harvest mouse eats insects and plants. The great horned owl eats reptiles, small mammals, and birds. A marsh rabbit eats plants and berries. Which one of these would most likely belong in position X on the food web? Well, let's see what it's eating. Okay, X is eating grass and grasshoppers, and it's getting eaten by snakes. So it's eating grass and grasshoppers. So we're looking in the box for something that eats plants and insects. A coyote eats small mammals, birds, and insects. And I don't see a coyote eating I don't see this eating any mammals, do you? A harvest mouse eats insects and plants. Ah, there we go. That sounds smart. Great horned owl eats reptiles. No, there's no reptiles going to that. Marsh rabbit's just plants and berries. So the correct answer is the red-bellied harvest mouse, because it says it eats insects and plants, and that's what this box is eating, insects and plants. All right, 3 more. The graph shows the lengths of shadows formed at different times of the day. We looked at this earlier. Early in the morning, when the sun's low in the sky, it makes a long shadow. And at night, when the sun's setting, or evening when the sun is setting, it makes a long shadow. At noon, it's right over our heads, so our shadow is short. Based on the graph, which statement correctly explains the length of the shadow and why the lengths change throughout the day? Okay, let's read them and see. The length of the shadow is shortest at noon because the sun is directly overhead. Yeah, that sounds right to me. The length of the shadow is shortest in the morning. No, it's longer in the morning. The length of the shadow increases throughout the day as the sun moves higher in the sky. No, the length gets shorter. The length of the shadow decreases throughout the day as the sun moves lower in the sky. No. The correct answer is A. The length of the shadow is shortest at noon because the sun is directly overhead. Number 23. A coin is placed in a half-filled glass of water as shown. When a student looks down at the glass, the coin appears higher than its real position. Why does the coin appear to change position when seen from above? Let's read the answers and find out. Light shines from the coin when it's at the bottom of the glass. Light soaks into the coin when it's at the bottom of the glass. Okay, I'm going to eliminate that because coins don't soak in water. They're made of metal. Light separates into other colors when it travels from the air to the water in the glass. No. Light bends when it travels from the air to the water in the glass. Ding, ding, ding. It's D. Think about the examples we looked at of refraction. When a pencil looks bent in a glass of water because the light is bent with refraction. So when we're looking at a coin, refraction causes that coin to look like it's in a different spot because the light is bent, moving from air into the water in the cup. So that answer is D. Last one for today. A student wants to create a telephone using 2 cups and a string. The student wants the telephone to reach as long as possible while still being able to hear words clearly. The student tests different types and lengths of strings, and records the results in a table. So fishing line at 20 feet can hear the words clearly. Fishing line at 60 feet can hear sounds, but the words are unclear. Kite string at 20 feet can hear words clearly. Kite string at 60 feet can hear words clearly. Wool at 20 feet can hear sounds, but the words are unclear. Wool at 60 feet, you can't even hear the words. So which string and length should the student use to create the telephone? Well, obviously it's going to be kite string. It's either 20 or 60. They're the same, so how do we know? Well, the student wants the telephone to reach as long as possible. So 60 feet is longer than 20 feet. So the answer is going to be kite string, 60 feet. That is C. All right. That's our science questions for today. Got some for you to try on your own. Be sure to come back and listen to the lesson tomorrow. We'll finish the last benchmark that you took. See you then.